So let us discuss the Stokes law. Stokes law defines the movement of an object in the fluid. So we can say when a body moves through a fluid, the fluid in contact with the body is drugged with it. The viscous force depends on the shape and size, speed, viscosity, and radius of the object. The force is expressed as the forces are expressed as weight that is acting downward is equal to the upthrust on the object plus viscous force on the object due to the liquid. So this viscous force can be considered as this is the motion of liquid in the downward direction. This object is moving downward direction. So viscous force is acting opposite to the downward direction, something in this way. So this is the viscous force, and upthrust is, this is the viscous force, and here it is upthrust. So weight of the body is mg, and upthrust is the weight of the object displaced m of water into g, m of water into g, plus viscous force is 6 pi eta r into v, 6 pi eta r into v. This is the force, viscous force. Now mass is equal to m, mass is equal to volume into density, So volume, if it is 4 by 3 pi r cube volume, if the radius of the object is r, and this is the density, the volume of solid. And mass of water is volume, the same volume, 4 by 3 pi r cube, that is the volume of water, and this is the sigma w, density of water, the density of water, that is liquid. So we can put the value ms, this is ms and this is mw. then it is 4 by 3 pi r cube rho s into g is the weight, and 4 by 3 pi r cube sigma w into g plus 6 pi eta rv, 6 pi eta rv. So we can find the expression for v. So 6 pi eta rv is equal to, transfer this one. So 4 by 3 pi r cube is common. So here it is sigma s minus rho s minus sigma w into g. This fine. So this pi is cancelled over here. R is cancelled. Here it is 2. So velocity is equal to 2 by 9 r square rho s minus sigma w into g. So this is the velocity of the object in fluid. So what we find, it is v proportional to r square and v proportional to the difference of the density, and g, difference of the density, proportional to r square, difference of the densities, and acceleration due to gravity. These are the three parameters. Means if there is a change in the planets, that is Earth, Mars, Moon, Jupiter, then we can have this kind of the variation. So now the graph is, that is velocity versus time. Here it is time or distance, you can say independent parameter, and dependent parameter is velocity. So the graph is something like this. Graph is something like this. So initially, this is the velocity increasing, and here it is constant velocity. After certain interval of time, and this constant velocity Vt from the graph, it is very clear that initially velocity will increase, but it will be constant after some time, and this is known as terminal velocity. This is known as terminal velocity Vt. Terminal velocity Vt. So we know that this velocity is free fall of the object, and this free fall of the object velocity has different way, that is some application, and that application is paratroopers. With this, there is one important concept at this moment, that is equation of continuity. Equation of continuity. This equation of continuity is, we have different cross-sectional area pipe. Here it is, the area of cross-section is A1. Here it is A2, and the length is L, and this point is duct, which is connecting, and this length is L2. This length is L2. This is the duct. This length is L2. So the product of, now the liquid flowing, here it is velocity V1 and coming out the velocity V2. So the product of area of cross section and velocity of liquid at the end, at the specific end, is constant. That is, A into V is constant. A into V is constant. Or we can say A proportional to 1 by V. A proportional to 1 by V. If area will increase, then velocity will decrease, or something different way. So we can have the plot something like this. This one is length, and here it is velocity. So if the area is wide, then velocity is low. So the velocity graph is again something like this. This point is V1, V2, and this point is V1, V1. So V1 is less than V2. And if we have another concept, that is the pressure, so we can have this pressure variation is something like this. This is pressure P2, and this pressure is P1. That is pressure. So the point where velocity is very high, pressure will low. Velocity is very high, pressure will low. If the velocity is low, then pressure will high. So it is used in various cases. The application area are important in this case, and that application areas are, you can see, applications. Then first is flow of liquid, in the canal. दूसरा, blowing of the roof by the strong winds. Strong winds. Strong winds means, suppose this is the rooftop of any house, and air flow in this way. This is the air flow. So if air velocity will increase, then the pressure difference is here. It is P1, and this pressure is P2. So their force is acting, and then this is the blowing off. This is the blowing off. And third is attraction between two closely parallel moving boats. Means if this is a boat and here it is another boat and these boats are moving in this way, so these feel a force of attraction. Here it is the velocity. This is the velocity V1, V2, boats. This is the velocity V1, V2, so feel attraction because the pressures are decreasing. Then Magnus effect. Magnus effect is related to cricket ball. Because if there is a ball, then there is lines, and the force is something V. The force is V plus minus R omega. If omega is the spin, and here it is the radius, so V plus minus R is the velocity effective, and this will make the total velocity, that is omega is spinning velocity. This is spinning velocity. Then एटोमाइजर आजकल बहुत कॉमन हो गया है, इसको हम कह देते हैं सैनिटाइजर। सैनिटाइजर का जो प्रिंसिपल है उसको पहले बुक्स में एटोमाइजर कहते थे। एटोमाइजर क्या है कि इफ इट इज बॉटल and here it is a tube, then this will spray over the air if this one is force. So this is droplets. Droplets from this liquid on applying the force over this point. Then there is a aeroplane wings. The aeroplane, that is this is the aeroplane flight, and here it is the wings. So wings of this plane is something they cut the air above and lower, and as the velocity will increase, there is a pressure difference, and this pressure difference will lift the aeroplane in the air. And then efflux velocity. The efflux velocity is again the same, that is the liquid flow through the tube, and here so V is equal to under root 2 G H. This is the height H. Here it is the liquid filled in the tube. This is. So all these are the applications area where these things are coming. Now we have one important theorem that is well known to everyone, which is known as Benoullis Benoullis theorem. Benoullis theorem states that for ideal liquid, ideal liquid का concept incompressible, non-viscous, incompressible and streamline flow. Streamline flow, ideal liquid. The total energy is what? Kinetic energy plus potential energy and then pressure energy. Pressure energy remains constant. It remains constant. So if we have the diagram, that is something like this. These are the two cross section, and here it is the ground flow. Here it is a ground. So liquid is flowing in this way. Here it is coming in this way. So here, this is the height. This is velocity V1, area of cross section A1, height is H1. Here the velocity is V2, area of cross section H2, height is H2. So what we find, this point is A point and this point is B point. So by the conservation of energy, EA must be equal to EB. So EA is the energy that is PA plus rho GHA plus 1/2 rho VA is equal to PB plus rho GHB plus 1/2 rho VB square. This is the kinetic square. So what we find, the work done that is PA minus PB is equal to, this is rho G HB minus HA plus 1/2 rho VB square minus VA square, VB minus VA square. And this is delta P into volume is equal to, this is M HB minus HA plus 1/2 delta M, that is M VB square minus VA square. So this is delta U plus delta K is equal to delta P. That is the conservation of mechanical energy. Delta P is nothing but it is for the work done. So delta W is equal to delta U plus delta K, and this is the mechanical energy conservation. So what we find here? We find at this point, there is a velocity head, and this velocity head is V square over 2G, and then the pressure head is P upon rho G, and then there is a gravitational head is H. So when the liquid flow from this point, so at this point, there are three heads, and these heads are constant. That is velocity head, pressure head, and gravitational head. That is gravitational head at these 3 points, and which is constant. And this Bernoulli theorem has a lot of applications in various fields, as well as fluid mechanics in biophysics. Now, one interested concept is flow of blood. The flow of blood in human body is being explained with the help of Poiseuille's formula. How this Poiseuille formula is? Suppose this is the tube. This is tube. Either it is vein or artery, whatever it may be. This is the tube. The length of tube is L, and the radius of tube is R. R is the radius. Then the pressure difference is P. So the quantity of fluid flow is expressed as Q is equal to P pi R to the power 4 upon 8 eta L. R this eta is equal to P pi R to the power 4 upon 8QL. So this is pressure is H rho G. This is the pressure, and this is P R to the power 4, 8Q and L. So this part is eta proportional to R to the power 4. Eta proportional to R to the power 4. And this Poiseuille has one experiment as well as. This is the experiment. And when this one is there, so it is the basic difference. If we have a tube of the radius R, and if tube is blocked, suppose this is the tube, and this tube is blocked with the cholesterol, something like this is deposition of the cholesterol. यदि कोलेस्ट्रॉल का डिपॉजिट हो जाता है तो ये एरिया कम हो गया, ये एरिया कम हो गया, यहाँ पे ज्यादा है। तो इस एरिया कम होने से द क्वांटिटी है वो डिक्रीज कर जाएगा, क्वांटिटी ऑफ ब्लड जो है डिक्रीज करेगा। और क्वांटिटी ऑफ ब्लड डिक्रीज करने से, क्वांटिटी ऑफ ब्लड डिक्रीज करने से देयर आर सो मेनी काइंड ऑफ द प्रॉब्लम, one of them is blood pressure as well. So this one is important to make care. और कोलेस्ट्रॉल को जो अब इसको ठीक करने की दो तरीका है। एक तो तरीका ये है मेडिकेशन। पहला मेडिकेशन ये है जो नॉर्मल करते हैं कि कोफिशिएंट ऑफ विस्कोसिटी को घटा दें, डिक्रीज इन वी विस्कोसिटी। तो ये कैसे होता है? थीन करके, थीनिंग फ्लूइड, ब्लड को थीन कर दीजिए, कोफिशिएंट ऑफ विस्कोसिटी, तो फ्लो इसका बढ़ जाएगा, अमाउंट बढ़ जाएगा, पहला। दूसरा तरीका है इसको बैलूनिंग करके, और बाईपास करके तीसरा। पहले बैलूनिंग मतलब इसके अंदर जो सर्जरी करते हैं, यहां से ये सर्जरी करके इसको काट के निकाल दे, ग्राफ्टिंग जिसको कहते हैं। ये है कोलेस्ट्रॉल, तो इसको काट के निकाल दें, और इसको काट के निकालने के लिए यहाँ से बैलून बेस्ड जो है डिवाइस को भेजते हैं और ये काट करके निकाल देता है। या तीसरा जो तरीका ये है कि ये ट्यूब है और यहाँ ब्लॉकेज है, तो ये एक बाईपास ट्यूब लगा देते हैं, दिस इज द बाईपास। तो बाईपास सर्जरी, दैट इज समटाइम इट इज कॉल्ड। सो इन दिस केस ये ब्लॉक है, ये ब्लॉक पीरियड है, तो दिस वन इज a bypass. So these are the remedies that are used in case of the fluid. अब इसके वजह से how much resistance is developed? पहला ही चैप्टर में हमने इसको थोड़ा डिस्कस किया था कि फ्लूइड रेजिस्टेंस जो होगा, fluid resistance is defined as R. R is equal to pressure difference upon quantity of liquid flow. So this pressure difference upon the quantity of liquid flow is dV by dt, dV by dt. And this value is from this equation. From this equation, it is 8 eta L upon pi R to the power 4. Pi R to the power 4. So 8 eta L upon pi R to the power 4. So resistance, again, this one is the resistance proportional to coefficient of viscosity. यदि coefficient of viscosity ज़्यादा होगा तो resistance ज़्यादा होगा। तो यदि coefficient of viscosity को घटा दिया जाए, जो कार्डियक वगैरह मेडिसिन आता है वो यही काम करता है कि ब्लड के थिकनेस को घटा देता है। इट्स मेक ब्लड थीन, और ब्लड थीन होने की वजह से, ब्लड थीन होने की वजह से इसकी कोफिशिएंट कम हो जाता है। कितना कम हो जाता है अमाउंट, उसको हम यहाँ से देख सकते हैं कि एवरीथिंग इज कांस्टेंट, तो Q1 अपॉन Q2 इज इक्वल टू दिस इज R1 अपॉन R2 के पावर 4। इससे न्यूमेरिकल क्वेश्चन आता है कि रेडियस या हाफ हो जाए तो R टू द पावर 4 264 टाइम्स जो है वो कम हो जाता है ब्लड। तो थोड़ा सा डिपॉजिट होगा तो बहुत ज्यादा ब्लड के फ्लो के ऊपर असर पड़ता है। तो दिस वन इज द इम्पोर्टेंट एक्सप्रेशन जिसके वजह से न्यूमेरिकल बनता है और उसके हिसाब से प्रॉब्लम्स क्रिएट हो जाते हैं। हार्ट के केस में इसी से जो पी वेव, आर वेव और एस वेव बनता है, हार्ट के केस में पी वेव, आर वेव और एस वेव बनता है, उसको यहाँ थोड़ा डिस्कस कर लेते हैं, हालांकि उसको that will be discussed in detail. This is the pulse. This pulse is here, something. This one is. So this is P wave. जो ECG हो रहा है. This is R wave. And this is S wave. This is S wave. So this time is 100 millisecond. Here it is, peak is very small, 0.0262 to 0.12 second, 12 seconds. TS wave, and this one is the 0.2 second, 0.2 second. So the whole region is P, Q, R, S, T. P, Q, R, S, T. And that give the information 6 into 10. 6 into 10. So 60 BP per second. 60 BP per second, that is pulse. That pulse is considered here. So these are the points that we have discussed here in this form, in the case of